configuration. This would be the some sort of the parameter, or we said it, these are the quantum numbers in which they are going to stay, like we are staying at homes. Or let's suppose this is the first division is like the Pakistan, and then it is having different cities and then different towns, and then it is our home. So in a similar way, these are the actually the residents of the electrons. So we will be simultaneously seeing their major distribution, and then we will moving to further subdivision, and then subdivisions of these electrons. So this is just was our objective. That means now you want to learn and to how we are going to distribute the electrons in the shells or the subshells, and these are called the atomic orbitals. So the first one is the principal quantum number, and the principal quantum number is shown by the n, and the value of n is 1, 2, 3, and so on. So it is very simple. I make it very simple to understand. So actually this is the again the shell we were discussing. This is the nucleus, and these shells are the where the electrons are going to be filled up. So this n is designated the shell, the circle, the first circle. If it is the first circle, this is called the 1, and it is the second circle, this is called 2, and similarly this is the third. And there are the specific names for the shells. If the value of n, or may you say this is the first shell, then it is called the k. And if
Patient.
the n, it is the principal quantum number, the value of n is 1, then it is called the k, and it is called the shells. Actually this n is designating the shells, and all these are the shells. And the second shell is called the L shell, and the third shell is called the M, and similarly the fourth shell is
Shell.
called the N shell.
And shell.
So with the number, you can remember. In the next we will do the exercise when there is n is 1, that means it is the k shell. So
Patient.
principal quantum number is giving you the information about the shells. So I think there is no any doubt over the first quantum number. If anyone you unable to understand, just let me know so I will explain it more. Otherwise, I will move to the next quantum number. Okay. So
Sir,
yes, please.
it is that simple. Principal quantum number is Shell's number.
Yes, it
Is
is the,
that simple?
it give you the indication about the shells. So how many shells are there? There are, let's for in this case, there are the four shell, but each
Four
shell is
shells.
designated with the symbol that is called the K, L, M, and N shells.
Yes, sir.
So this is
Okay.
only give you the information about the shells. So this is that's why this is called the principal quantum number. This is the principal number that just give you the information about the shells, nothing else. Okay, now we
Okay,
are
sir.
moving to the second quantum numbers, and you must remember all these quantum number are very important. If you remember what is the function of these quantum number, then you will be able to fill up the electrons in the shells or the subshells or the orbitals. So let's suppose the second one is the angular quantum number, and it is shown by the small l. And the first we will do what is going to give us the information. This is the three-dimensional shape of the orbital. And let's suppose this is the orbital. One orbital is this, second orbital like this, and third orbital is like this. So don't worry about the shape of the orbitals. This is just for you to understand that there is what is the difference when the shape like this, or when the shape is like this. So because you do not need to remember the shapes, or this is not included in your syllabus as well. So
Yes.
again, this angular quantum number is shown by the small l. And how can you calculate? This is a very simple formula. This is the n minus 1, and you remember n is the principal quantum number, as we have discussed in the previous slide, which was our first quantum number. So when value, then how can you calculate? Just put the value of n over here and get the value of L. So L will be equal to n minus 1. So when the value of n is 1, that means we are talking about the K shell. Then 1 minus 1, the value will be equal to 0. So when L will be 0, that means we are talking about this, the shape of the orbit. We will name this orbit later on, but here just understand what is the, how can we are going to calculate the angular quantum number, and what about its shape. So similarly, if n is 2, if n is 2, that means we are talking about the L shell, because when the value of n is 2, that is called the second shell, and second shell is called the L shell. So 2 minus 1, the value will be 1. And similarly, we will actually, it is the distribution of the orbital. It is going to start with the 0. The first one is the 1, and we will moving to the 0. So first, the 2 minus 1, the value is 1. And then there is the additional value that is called the 0. Later on, I will explain this one. So let's finish with the, when value of n is 3, that means we are talking about the KL and M shell. This is the M shell. N equal to 3, this is the M shell. And 3 minus 1 will be, the value is 2. So you have to move to the 0. So before 2 it is 1, and before 1 it is 0. So this is very simple to understand. What about the angular quantum number? It is shown by the small n, and this is the way how you are going to calculate the value of the n. And this may be the value of 0, 1, and 2, and so on. If it is value, let's suppose if the value is 4, then 4 minus 1 is 3, and then 3, and there will be the 2, there will be the 1, and there will be a 0. So 0, 1, 2, 3 for the value of the n, when there is a value of n will be equal to 4. So now this is the final outcome of the angular momentum. Similarly, when the principal quantum number is giving you the information about the shells, and this angular momentum quantum number is giving you information about the subshells. So here you can say there was only, in the principal quantum number, there was only K, L, and M shells, and here it is the this will give you the information about the subshells, and these are the subshells. Actually, in the first slide I have shown you the distribution of electron s, p, d, and so on orbitals. So we have already calculated the quantum number L, that is the angular quantum number, in the previous slide over here. This is 0, 1, or 2, and these are the name of these subshells. So when the quantum number L is having the value 0, then it is called the S subshell. When value is 1, then it is called the P subshell. When value is 2, then it is called the D. And similarly, when value is 3, it is called the F subshell, and so on. Further is this G, H, I, but in the current periodic table, we just going to fill up the electron with these four subshells. And you must remember, maybe I have asked you one of the question in your quiz, how can you divide the periodic table into the blocks, and we discuss about there were four blocks: S, P, D, and F blocks. Actually these F blocks are coming from the angular quantum number. So no, this is their specifically it is written over here. S mean it is sharp, P is principal, D is diffuse, and F is the fundamental, because these are main concern to our periodic table, and then rest it will go on GH and so on. So now finally, what is the outcome of this angular quantum number? You remember the value of L, and then what would be the subshell notation. If the value is L is 0, it is called the S. If the value of L is 3, it is called the F subshell. So this quantum number is giving you an indication about the subshells. Now moving to the further quantum number, Similarly, you must understand what I have given you the example. The first is you are living in Pakistan and you are living in Lahore. Actually, we have finished with the two one quantums. The first was the principal quantum, which was, you can consider this is the Pakistan, and the second we discuss about the subshells, and you may consider it this is now the city in Lahore, and in a similar way the electrons are going to stay in the orbitals. And the third one, now if you are living in Lahore, then let's suppose you are further is the in specifically in Lahore there are many towns, and let's suppose you are or many locations. Let's suppose you are living in the DHA or the other Askari flats or somewhere else. So actually this is the further division, actually location of the electron where these electrons going to be filled up, and this is called the magnetic quantum number. And how can we first you have to calculate, and this is again the very simple formula for the magnetic quantum number. And what is this gives you the spatial orientation of the orbital. And here just have a look over here for your reference. We discussed in the previous slide, when the value of L is 1, that is called the P or P subshell. And here you can say P shape cell may be oriented like this, maybe oriented like this, and maybe oriented like this. So this we call, these are the different axes. This is the x-axis, this is the y-axis, this is the z-axis. So here there is the three type of the orientation of the p orbitals, and this is all about the magnetic quantum number. So this will give you the information about the orientation of the orbitals, and that is the magnetic quantum number. And second, how can you calculate? This is the 2L plus 1, and L is the angular quantum number, as we have discussed in the previous slide. So the principal quantum number you will use to calculate the angular quantum number, and here for the magnetic quantum number you will use the sorry, for the magnetic quantum number you will use the angular quantum number. So these are related to each other. If you mistake in the first, then it will automatically wrong with the rest of the quantum numbers, because the information you are getting from one quantum number you will be using to put the value and getting the answer for the second quantum number. And again, this is 2L plus 1. L is the angular quantum number, and the value are written over here. We have already studied the value of L is 0, and you know when it will be 0, when the value of n is 1. So 1 minus 1 will be equal to 0. So when value is 0, there is only one orientation. It doesn't mean it is 0. It is giving you the information that it is having one orientation. That means there is no other than orientation to one orientation. So like let's suppose this is the spherical molecule, or the if you there is a ball, and if you rotate the ball, there is no orientation. Actually the orientation will remain the same. That means it is only having the one orientation. Second, when the value of L is 1, so you put the value 1 over here. 2 multiplied by 1 is again 2, and 2 plus 1 is the 3. So total output of this one is the 3. So the value of this you are going to arrange. So total orientation of 3, this is 1, 2, and 3 orientation. So how can you label this one? This is the 0, and you have to move plus 1, and 1 is the minus 1. So 1 is you are going to add 1, and then you are going to subtract 1. This is the orientation of the this magnetic quantum number when it is having the value of the L. And let's suppose when the value of 2, then if you put the value of 2 over here, 2 multiplied by 2 is 4, and plus 1 it is 5. So that means when value of 2 is 2, it will give you the 5 orientation, and 5 orientation are given over here. So you have to start with the 0, then plus 1, minus 1, these are 3, then plus 2, minus 2, these are 5. And similarly you can do with the third one. again there should appear plus 3 and there should be minus 3. So how many orientation are there? If the value of 1 is 0, there is only one orientation. And when value of L is 1, there is 3 orientation. And when value of L is 2, there are 3 orientation. So this is all about the magnetic quantum number. So this is just for your reference, not included in your syllabus to remember the orientation. I'm just giving you the idea actually how the orbitals look like in shells. So this is the s orbital, and all s orbital is having the spherical shape. Like this is the, let's suppose this s is present in the k shell, this s is present in the l shell, having the two circle, and this is 1, 2, and 3. This is actually present in the 3s, and 3, 1, 2, 3 is giving you the shell. That means we are talking about the principal quantum number. So this is the principal quantum number, and s is giving you is only having one orientation. So this is the all s should have the same orientation, and this is the spherical shape. That's why this must have only one orientation. The second one is the P, and P, as we have discussed, the P is having the three orientation. This is these are the different axes are written over here. This is we call, because there are three orientation, we call them PX, PY, and the PZ. So you may have a look over this different orientation, and different orientation. And similarly, as the D is having the 5 orientation, and what is the shape of the d orbital? It is the clover leaf like shape, and this was the dumbbell like shape for the P, and S was the spherical shape. So these are all about the shapes of the different molecules, the orbital present in the shells and the subshells. So this is all about we have talked about the three quantum numbers. One is the principal quantum number, second was the angular quantum number, and third was the azimuthal quantum number, say magnetic quantum number. And now I think the time is ending because we have passed to the 40 minutes. So before ending this one, I request you to first mark your attendance, and then I will close this meeting and you must join again. We will do very simple exercise, so you must remember what we have discussed right now. So first, please mark your attendance in the chat box. So I will save, just put your name and your roll number. So I will mark your attendance later on. So after 1 minute, I will be ending this video and you must join again. So it would be better. We will do some very little exercise. So you will remember or refresh your knowledge. How can we distribute the electrons in the shells, or how can we calculate the shells or the subshells or the orbitals? So four are left, please mark immediately, so because before it is going to end the class. So okay, so I'm going to end and then please rejoin me again.